History of blockchain. The underlying technology behind cryptocurrencies is the blockchain. It allows every client in the network to reach consensus without ever having to trust each other. The idea behind blockchain technology was described as early as 1991, when research scientists Stuart Haber and W. Scott Stornetta introduced a computationally practical solution for timestamping digital documents so that they could not be backdated or tampered with. The system used a cryptographically secured chain of blocks to store the timestamped documents, and in 1992, Merkle trees were incorporated into the design, making it more efficient by allowing several documents to be collected into one block. However, this technology went unused, and the patent lapsed in 2004, 4 years before the inception of Bitcoin. In 2004, computer scientist and cryptographic activist Hal Finney introduced a system called RPOW, Reusable Proof of Work. The system worked by receiving a non-exchangeable or a non-fungible Hashcash-based proof of work token, and in return created an RSA signed token that could then be transferred from person to person. RPOW solved the double spending problem by keeping the ownership of tokens registered on a trusted server that was designed to allow its users throughout the world to verify its correctness and integrity in real time. RPOW can be considered as an early prototype and a significant early step in the history of cryptocurrencies. In late 2008, a white paper introducing a decentralized peer-to-peer electronic cash system called Bitcoin was posted to a cryptography mailing list by a person or group using the pseudonym Satoshi Nakamoto. Based on the Hashcash proof-of-work algorithm, but rather than using a hardware-trusted computing function like the RPOW, the double spending protection in Bitcoin was provided by a decentralized peer-to-peer protocol for tracking and verifying the transactions. In short, Bitcoins are mined for a reward, using the proof-of-work mechanism by individual miners and then verified by the decentralized nodes in the network. On the 3rd of January 2009, Bitcoin came into existence when the first Bitcoin block was mined by Satoshi Nakamoto, which had a reward of 50 Bitcoins. The first recipient of Bitcoin was Hal Finney. He received 10 Bitcoins from Satoshi Nakamoto in the world's first Bitcoin transaction on the 12th of January 2009.
Bitcoin is the first decentralized digital currency. Bitcoins are digital coins you can send through the internet. Compared to other alternatives, Bitcoins are transferred directly from person to person via the net, without going through a bank or clearinghouse. This means that the fees are much lower. You can use them in every country. Your account cannot be frozen, and there are no prerequisites or arbitrary limits. Let's look at how it works. Several currency exchanges exist where you can buy and sell Bitcoins for dollars, euros, and more. Your Bitcoins are kept in your digital wallet on your computer or mobile device. Sending Bitcoins is as simple as sending an email, and you can purchase anything with Bitcoin. Bitcoin network is secured by individuals called miners. Miners are rewarded newly generated Bitcoins for verifying transactions. After transactions are verified, they are recorded in a transparent public ledger. Bitcoin opens up a whole new platform for innovation. The software is completely open source and anyone can review the code. Bitcoin is changing finance the same way the web changed publishing. When everyone has access to a global market, great ideas flourish. Bitcoins are a great way for businesses to minimize transaction fees. It doesn't cost anything to start accepting them, and it's easy to set up. There are no chargebacks, and you'll get additional business from the Bitcoin economy.
In the digital world, cryptocurrency is increasingly becoming a buzzword everywhere. But not everybody is aware of the basics of cryptocurrency. Cryptocurrency is an electronic-only digital currency that is intended to act as a medium of exchange. The decentralized mode of cryptocurrency makes it escape the central authority. Bitcoin is the first cryptocurrency that saw wide adoption in the market. Based on blockchain technology, Bitcoin was launched in 2009 and was designed to electronically copy features of a cash transaction. The blockchain technology behind Bitcoin records the transactions and the ownership of the digital currency. The movement of Bitcoin is recorded and updated on a public network, often referred to as a distributed ledger. Today there are over 10,000 cryptocurrencies in the market. Not all of them share the same value and growth. While Bitcoin is seen as a digital asset, Other famous cryptocurrencies are Litecoin, Cardano, Polkadot, Bitcoin Cash, Stellar, Chainlink, Binance Coin, Tether, etc. Some cryptocurrencies like Tether are vouched with national currencies like the American dollar. Before investing in cryptocurrency, one thing you should keep in mind is that digital currency values are very volatile. They can take you to the peak and also push you down from there.
Ethereum, as the market leader, is in a scalability crisis, but it appears that we may not have to wait much longer for lower transaction fees. With Layer 2 solutions, it's likely the Ethereum platform's success is well begun. But what exactly are these Layer 2 projects, and how do they work? And why do we need Layer 2 solutions? You've probably heard about the high gas fees that Ethereum users must pay to make transactions on the network. With the overwhelming transaction volume on Ethereum, it's becoming a who-can-afford-to-pay system for your transactions to go through faster than other users on the network. Today, users might have to pay several $100s just to complete a single network transaction. During the recent Otherdeeds land sale, gas spiked to as high as 8,000 Gwei, and users had to pay over 2 ETH just for transaction fees. It's no secret that high gas fees are causing a major scaling crisis for Ethereum. Firstly, they must find a way to accommodate millions, if not hundreds of millions, of people in the future. Also, they need to run more transactions per second. Ethereum's capacity cannot allow it to perform large numbers of transactions per second. Most importantly, Ethereum needs to maintain the network security and high level of decentralization. So how can Ethereum sustain blockchain scalability, security, and decentralization Trillium so that the entire system does not collapse? Layer 2 solutions are a way for Ethereum to scale blockchains. Before Layer 2 solutions, Ethereum ran the blockchain in a monolithic manner. This means that everything was done on the blockchain itself, from transaction processing to security protocols to data integrity. However, Ethereum is currently adopting a modular approach that makes use of a multi-layer system. So rather than handling everything on its own, the blockchain delegates some of the work to other layers of the network. So in this case, Layer 2 operates on top of Ethereum, which is also referred to as a Layer 1 blockchain. Other Layer 1s you may use are Bitcoin, Solana, Binance Smart Chain, and more. How do Layer 2s work? Layer 2 solutions usually execute transactions outside of their underlying network. Once done, they send back compressed forms of the transactions back to the network. In this way, Layer 2 performs the execution part, while Layer 1 performs the security and final data storage. Many Layer 2s can run simultaneously on top of Ethereum. This means that you can have a much higher number of transactions running per second. Ethereum can be scaled up in the future. It will also be fast while retaining the blockchain's security and integrity. The most exciting Layer 2 solutions. Since many Layer 2s can run simultaneously on top of Ethereum, many projects have emerged over these last few months. Each new Layer 2 solution will often tweak the code of its predecessor to boost efficiency, the most exciting of which are Arbitrum, Optimism, ZK Sync, Starknet, and Metis. These projects generally fall under 2 categories: optimistic rollups and ZK rollups. Let's look at how these projects differ from one another. Optimistic Layer 2 rollups. There are 3 major types of optimistic rollups: Optimism and Arbitrum and Metis. The Optimism project is the preceding Layer 2 solution, which uses single-round fraud proofs and relies on Layer 1 to execute Layer 2 transactions. As a result, the fraud-proof verification process is instant, but it incurs extra gas fees due to its reliance on on-chain Layer 1 execution processes. Arbitrum, on the other hand, saw this problem and tweaked Optimism's source code to implement multi-round fraud proofs. This way, transactions are not entirely executed on Layer 1. Metis, a hard fork project of Optimism that offers a higher level of decentralization. It does this using multiple sequencers as opposed to one, as Optimism does. It also uses its own virtual machine called the Metis Virtual Machine, MVM. Since the Metis launch, there has been a lot of excitement and increasing interest around the project, particularly because it uniquely uses its own token. Why are they called optimistic rollups? These 3 rollups are known as optimistic rollups because they employ an honor system in which the smart contract on Layer 1 does not validate that Layer 2's state changes were done correctly. Optimism and Arbitrum do not have their own tokens. They instead use wrapped ETH, which has a 1-to-1 ratio with the ETH token. As a result, they both have cross-chain ERC20 token compatibility. We also have zero-knowledge rollups, ZK rollups, like ZK Sync and Starknet. They are also tokenless and perform similar to optimistic rollups in that they compress large off-chain transactions and submit them as a single transaction onto Ethereum. The main difference is that Ethereum smart contracts won't take the off-chain transaction in good faith. Instead, ZK rollups require a zero-knowledge cryptographic proof that all the transactions were carried out correctly. In the end, each batch of transactions will have its own validity proof sent to Ethereum. In fact, Arbitrum is the leading solution of all other Layer 2 projects, with the most users and the highest billion total value locked (TVL) in smart contracts. Currently, users prefer Arbitrum for Ethereum scaling. Arbitrum has lower gas fees and an automatic Arbitrum Virtual Machine (AVM) to Ethereum Virtual Machine (EVM) translation, which encourages dApps to go with Arbitrum for its total control over executing smart contracts. The future of Ethereum goes, Layer 2 technologies are looking bright for the market leader. Hopefully these projects continue to solve the congestion issues and high gas fees that users currently have to pay to use the platform.
What is Web 3.0? Let's start with 1.0, an initial overview of what the internet was. Between the years of 1991 and 2004, the internet was mostly a bunch of static pages, meaning that whenever you loaded them, they just showed some stuff and that was it. Some called it read-only. There wasn't any logging in or interacting with posts or viewing analytics. Most of the early internet wasn't even profitable by ads. It was mostly just like one big Wikipedia, all hyperlinked together. Now, of course, with time, we slowly made improvements, and things like Flash and JavaScript added many new different features. However, during this time, the users of the internet were consumers. They went to the internet to consume information. Next, we have Web 2.0, from around 2004 until now. During this time, the web evolved a lot, but one of the biggest changes was the interactivity of the internet. This meant that not only did we get information from pages, but the web pages started getting information from us. As we viewed Facebook and YouTube and performed Google searches, these centralized companies started collecting data about us so that they could serve us better content, which in turn would make us stay on their websites longer. This meant more money for them, but eventually they realized they could package up all the data they had collected on us and sell it to advertisers. Web 2.0 is the age of targeted advertising and the lack of privacy for its users. Now, to be fair, we willingly gave up this privacy too for cool apps like Facebook and Twitter. In Web 2.0, me and you could both view Facebook.com and see 2 very different news feeds because the page depended on who was viewing it, which is an important note for a difference in Web 3 that we'll talk about in a minute. The content on your feed is the company sorting data by information that you know that you gave them, like likes and how much you watched a video. But if you look at the ads that they show you, that is them sorting data by information you didn't know you give them. When you went to go eat tacos last night, they knew that. When you drop your kids off at school every day at 8 a.m. except for Fridays, they knew that. And there was even that one article that said machine learning started showing a guy some parenting ads because they knew he was going to be a father before he did. If it wasn't machine learning, it was probably because his girlfriend used their public IP address to do a search on her symptoms. And the machine learning algorithm probably already knew when she was ovulating anyways. Whatever the case is, how they predicted this, one centralized company controlling all of this data, whether we want to or not, is scary. Next up is Web 3.0, and this is what you came to learn about. Web 3.0 is the next evolution of the internet, probably utilizing blockchain technology and the tools of decentralization. In Web 2.0, you were the product as you were browsing social networks. But in Web 3.0, some believe that you will be the owner of your content, the stuff that you post online. Now this is kind of true, so if you want a post to stay up, it'll stay up, but if you want to take it down, they say in Web 3.0 you can control that, because as we all know, usually when something is on the internet, it's always on the internet. Here's one example that's already real. Odysee is a blockchain alternative to YouTube, where videos can be posted and creators can earn library tokens, which are basically a reward for enticing viewers to watch their videos. The thing about Odysee though, is that they can't really stop a video from being posted. If someone uploads it and someone else in the network wants to share it, they technically download that video and then let others watch that video and download it as well, kind of like a big torrent network, if you know what that is. To expand on this, your post couldn't get taken down because your post wouldn't just be on one of Facebook's servers. It would theoretically be on thousands of computers around the world, ensuring that the blockchain social network you're on is not attacked or censored. Theoretically, this means there would be a lot of illegal and hateful things posted, but it would be in the name of freedom, of which the users of the networks could probably decide on a system to reduce that harmful content. But that's for another video. In Web 3.0, experts say that we will reach the point of the internet where every company is ran by a decentralized group called a DAO, which stands for Decentralized Autonomous Organization. And if you want to learn more about what those big words mean, we have an entire video on that topic and what they are used for. However, DAOs mean that there are no CEOs or presidents to impress. Those with the most tokens get to vote on how the company changes, not limited by a government or some family tradition. In Web 3.0, there will be no censorship of social networks like Facebook or Twitter. One controlling authority cannot shut it down. Lastly, one of the biggest things in Web 3.0 is that your digital identity is not 100% connected to your real-world identity. This means I can view pages, download things, make purchases, and any other activity on the internet without being traced to the real me. Now, there are many ways we can anonymize ourselves online, but bingo, I think that might be a future video idea. These may be long-term ideas of those who think about Web 3.0. What Web 3.0 really means for us is that in the next decade, you might be able to buy Amazon gift cards using MetaMask and pay with Ethereum, or that you could anonymously leave a like on one of your friends' posts using one of your hidden wallets. It's not going to be a bunch of life-changing stuff all at once. It'll likely be a series of ideas that grow together until centralized companies like Facebook and Google are disassembled by legislature, while decentralized, unregulated DAOs grow to replace them. I also want to talk a bit about the Web 3.0 Foundation. Now, there is a company called the Web3 Foundation that supports projects for increasing decentralization on the internet. Their three big projects are the blockchain Polkadot, Polkadot's test chain, and the Web3 Summit, which isn't a good overview of what Web 3.0 actually is. But they also offer some grants, which a lot of them have to do with supporting and using the Polkadot blockchain. So it seems to me the Polkadot team used the Web3 name as a brand to push their own agenda. But that's not what this channel is about. To give you an understanding of what I mean by this would be like the company Facebook buying a foundation for Web 2.0 and saying they are the ones who initiated it. Facebook is a company, while Web 2.0 is an idea. The same way that Polkadot is a blockchain and Web 3.0 is an idea. One doesn't own the other.
This is John. John runs his own business. He has a local IT company, developing new application. He wants to grow up his business by entering in the blockchain technology. But John has a big problem. He's got too much to do, and he can't find any qualified blockchain project. Then one day, John found the Ergo. Ergo was able to provide John's needs, and match with all of his desires. But, what is Ergo? Ergo is an open platform that allows businesses to build innovative applications and services by sharing data on a trustless and distributed IT ecosystem. Ergo has three major architectural functions, which together form the Ergo platform. Ergo Chain is a proposed blockchain designed to mitigate issues currently experienced with public blockchains. It aims to include an SQL-based smart contract platform as well as advanced features, such as distributed version and concurrency control. Ergo Hub is a blockchain hosting service that acts as the public interface for building, testing, deploying and managing independent blockchains based on Ergo Chain. Ergo Marketplace aims to enable the sale and purchase of peer-to-peer computing assets. Now John have a wide selection of tools on blockchain 4.0 to choose from. Thanks to Ergo, John can now sit back and relax, knowing that he can build his own blockchain system within 3 weeks with Ergo.